Hello, Doctor. My name is Yuvegan Rao. My student ID will be DN 2012. So today I am representing Group 8. We'll be presenting our statistics project. So our study is based on people's sleeping pattern. Without further ado, I will proceed to the next slide. Right, so here I would like to introduce you to my group members. First of all, we have Vinod, Shiva, and then myself, Yuvegan Rao, Magdelene, Moses, and also Navenkumar Selvam. So the roles in this project is myself and Magdelene. We prepared the slides, and coming to report completion, Vinod and Navin took over. Okay, so introduction to statistical management in industrial. Improved manufacturing quality in Japan over 20 years. Corporate efforts to boost statistics education via simulation, real data, and practical examples. Engineering technology students learn key statistical concepts and problem-solving strategies across 6 chapters. So this course covers random variables, special probability distributions, sampling distribution estimation, hypothesis testing, and simple linear regression. Finally, statistical engineering involves designing software or modeling visual analysis, merging engineering and stats for practical solution and reports. Right, so the objectives of our project, of our case study is first to analyze and understand sleep patterns for specific demographic or population. Secondly, to determine average sleep duration, variations among different age groups, and any correlations between sleep patterns. Thirdly, to analyze and understand the sleep efficiency and wakefulness. All right, so here is about the case study. We started establishing the research aim and objectives concerning all age people's sleep patterns. So we can first establish the study's focus. Next, we decided on what the research questions are and what they mean. Sleep patterns, awakening time, sleep efficiency could be the focus of the study. So as you can see here on the screen, Doctor, this is the data we have collected based on the study taken, on the research taken. So chapter 1, heading to chapter 1, we have random variables, we have discrete random variables, and also continuous random variable. Apart from that, we have a case study, and then we have mean of random variable, which is mean, mu is equals to sum of xp in x in bracket. And then we have variance of random variable. So this is the data for awakenings, as you can see on the screen, Doctor. All right, coming to the question, probability distribution function, PDF. So the question is, suppose x denotes the number of sleep patterns by the student. From an examination of the awakening, tabulate the probability distribution functions. So as you can see, this is the table consisting 5 values of x's. This is about the CDF, also known as cumulative distribution function. So the question sounds like, suppose x denotes the number of sleep patterns by the students. From the probability distribution function table above, find the cumulative distribution function of x. So as you can see, here is the working that we got. I'm sorry if it's not clear, Doctor, but we have a clearer one in the report. As you can see here, this is about the mean and variance, Doctor. So the question sounds like, suppose x denotes the number of sleep patterns by the students. From an examination of the awakenings of 30 students, calculate the mean and variance. So as you can see, Doctor, the mean we got here is about, the variance here we got is 2.83, and the variance will be 4.99. Getting into chapter 2, Doctor. So in chapter 2, we will cover the binomial distribution, the Poisson distribution, as well as normal distribution. So getting into binomial distribution. The binomial distribution describes the behavior of a count variable x if the following conditions apply. So the first condition will be the number of observations n is fixed. Each observation is independent. Each observation represents 1 or 2 outcomes, which is success or failure. And the final one will be the probability of success. P is the same for each outcome. Getting into Poisson distribution. The Poisson probability distribution is often used as a model of number of arrivals at the facility within a given period of time. For instance, a random variable might be defined as the number of telephone calls coming into an airline reservation system during a period of 15 minutes. If the mean number of arrivals during a 15 minutes interval is known, the Poisson probability mass function given by equation 7 can be used to compute the probability of x arrivals. Getting into normal distribution. Normal distribution has the following features, which is symmetric bell shape. Mean and median are equal, both located at center of the distribution. 68% of the data falls within one standard deviation of the mean. So the case study based on special probability distribution. The question sounds like, one of the surveys in Malaysia has an average of 30 out of every 100 people. A random sample of 30 people's sleeping patterns is selected. Find the probability that exactly 20 awakenings, less than 25 awakenings. So this is what the data we have collected. based on the awakenings and the amount. And here you go, the solution for this special probability distribution. What we got for the first one is 0.000296, and for the second one is 0.9999997. Coming to chapter 3, sampling distribution. Sampling distribution shows statistic variability from multiple samples of the same size from a population. Revealed sample means values and their probabilities, aiding understanding of its behavior, shape, and shape of distribution crucial for insights into its estimated population parameters. And the final one is vital in statistical interference, allows estimation of confidence intervals, hypothesis testing, and outcome likelihood predictions. As you can see, these are the calculation for probability of single mean. Step 1, step 2, step 3, and step 4. And then here we have the question and the solution, which we have included in the report of them. Getting into chapter 4, so the features of a sizable set of items such as people, homes, buildings, goods, parts, clients, etc. are frequently of interest. The population is made up of all studies relevant factors. Data frequently cannot be gathered from every segment of the population due to time, expense, and other factors. In these circumstances, data are provided by a sample, which is a subset of the population. The characteristics of the wider population are then estimated using the data from the 18th sample. Statistical inference is the method of drawing conclusions about a population from a sample. The term parameters of the population refers to characteristics like the population mean, variance, and percentage. Large sample estimation of a population mean. An estimate of the population mean together with a reliability rating may be found in a confidence interval for a population mean. Coming to small sample estimation of population mean, we should ask ourselves two questions. Is the population standard deviation known or unknown? And is the sample large or small? These questions will help you choose the best formula for building a confidence interval for population mean. Getting into large sample estimation of a population proportion. So we have a single formula for a confidence interval for a population proportion, which is valid when the sample is large. The condition that a sample be large is not that its size and be at least 30, but that the density function fits inside the interval 0, 1. Estimation procedures for two populations. So the estimation procedures can be extended to two populations or comparative studies. For example, suppose a study is being conducted to determine differences between the salaries paid to a population of men and a population of women. Two independent simple random samples, one of the population of men and one of the population of women, would provide two sample means, s to the power of -1 and x to the power of -2. Case study for estimation, confidence interval for single mean. So as you can see on the screen, doctor, this is the data collected for large sample, and it's more than or equal to 30 or deviation known. As you can see, this is the table and the question. So this will be the solution where we have collected all the data. So n is equals to 30, x is equals to 2, s is equals to 1.287. Deviation is 1, obviously 1 minus 0.5, 0.95. So the answer, the deviation will be 0.05. So we'll get an answer of 1.539 is less than mu, but more than 2.42, but it is less than 2.461. That's it from me, doctor. I will pass this topic onwards to my fellow members. Thank you.
Hi, doctor. So the following chapter will be continued present by me. So the chapter 5 is hypothesis testing. So a methodical process for determining whether research study findings are consistent with a specific idea that pertains to a population. So to evaluate a hypothesis about a population, hypothesis testing uses sample data. The major purpose of hypothesis testing is to choose between two competing hypotheses about the value of population parameters. There are two complementary hypotheses in hypothesis testing, which are null hypothesis and the alternative hypothesis. The null hypothesis symbol is HO, basically answers no, there's a no effect in the population, while the alternative hypothesis H1 answers yes, there is a effect in the population. So steps in hypothesis testing, there are 5 steps. Step 1, write the original claim and identify whether it is the null hypothesis or alternative hypothesis. Step 2, use alternative hypothesis and determine the type of test. Write down all the information from the problem and find the critical value using a table. Step 3, compute the test statistics. Step 4, decide to reject or not the null hypothesis. Step 5, write the conclusion. So case study, hypothesis testing. A random sample of 30 exercise frequencies were collected. The average exercise frequency based on the data collected is 2, assuming a population standard deviation is 1.287. Does this seem to indicate that the mean exercise frequency is larger than 2? Use a 0.05 level of significance. So these are the solution for the question just now. So according to the step 1, step 2, step 3, and step 4, and step 5, as I mentioned before. So finally, for the chapter 6, simple linear regression. Case study, simple linear regression. So the introduction, linear regression is a supervised machine learning technique used to predict continuous fixed slope values such as sleep duration by simulating a linear connection between independent and dependent variables. So the case study, in this case study, our objective was to determine the sleep duration and the age of the person had any detectable relationship. An appendix at the conclusion of the paper contains the data set that was used for this investigation. Since there are only two variables for the which we have a data, we consider fitting a straightforward linear regression model to the available data set. So here are the sample questions following with the steps for the solutions. So starting with 8.1 until 8.4. So conclusion, statistics is a branch of mathematics that collects, inspects, and analyzes data to draw conclusions using quantified models. It is used in economic and financial decision making for random experiments, binomial distribution, sample distribution, estimation calculation, hypothesis testing, and regression analysis for complex events and relationships. So that's all for me, Doctor. So I'm here to say thank you for the whole semester that you taught us throughout the whole semester. The knowledge you share with us, we are very grateful for that. We as a group members of 4 pillars like me, myself, Vinod Shiva, Yuvegan Rao, Magdelene Moses, and Navenkumar will be very obliged and thankful for your services and uh, and your knowledge you share with us. Thank you very much, Doctor.